part of the process. It will be the state here until process ends. So which means if you create a lot of global variables, all variables are global, you will keep more and more the resource, memory resource. Okay, that is one of the reasons the global variable is not recommended. Okay, but in case you have the global variable, it will be stored at the separate area. That is the data section. So text section, data section. Then there are two parts. All the other. So during the processing of the instruction, as you can see over here, some of the data are the temporary data, which means, for example, for loop in the local variable, I and for example, we define the integer I. So this I will be affected inside of this loop, this block. So once we out of the loop, we don't need this one. In case of the for the loop inside the loop, I, J, and K, and so on. Then once we out of the loop, we don't need such a variable. Okay? Mostly local variable, and also this is a temporary variable, temporary data. A lot of the data are temporary. So to process the logic, we need some variable, but that will be just supplementary. After we got the final output, that is the out variable, so we don't need I, J, K, and so on. So this temporary variable will be stored at the top end of the process, higher memory address. For what? Because why here? We are going to use the stack, data structure. This is called the stack area of the process. What is a stack? First in? First out? It's last out. Okay? So stack is like our bin. So you can stack up the laundry, then you can take up from the top. Okay? So like to stack up your book, and so you learned in your CS 102 or the data structure class in your undergraduate. That is a stack. What is the benefit of the stack? What is the characteristic? Main characteristic of the stack? It's very fast. So I think the fastest the data structure. Why? What's the difference between the other general data structure versus the stack?
Because you're always accessing on the top of the stack. You're always accessing from the top of the stack.
Which means it's a very restricted operation. As you know, the general data structure has the insert, update, delete, and fetch. The update is the delete and the insert. So you probably know. Then we can analyze each data structure using pivot notation or the memory density. Do you remember that? That is the basic, the computational, the process of the data structure. Okay, then the stack is, in terms of pivot notation, what? Over 1, fastest one. Why? It doesn't matter how many data we have, it's always even not linear. It's the same, the complexity. Why? Because, as she mentioned, when we fetch and the resource of fetch and delete, a lot of time when we read the data, it's used, okay? Which means gone. So if you pull out the tissue, then are you going to put it back? No. After you use, you throw away. A lot of the data is the same thing. After we use, we don't need a lot of time. So fetch and delete. So where? It's always top. We don't have to find where it is. Always top, top, top. Okay? So we are going to use such a stack structure. First reason is fast. Okay, and also a lot of time, as we can see, is if we follow the procedure, we use this one, I and J. When we out, usually inside and outside, this way. Which means we can use the step. Inside I, J, K, then the most inside the loop use, then the take out, fetch, and delete. Okay, it's called the POP. And the POP, and finally outside. So that can be used to handle such a temporary local procedure and keep the local variable. So we are going to use the stack area for temporary. Okay. So why? First reason, fast. Most fast. Fastest approach. So we will use such a stack. Another. So then there's another area. So we'll have the text is the instruction code. Data is a global variable. Then local variable will be used here. Okay. So local variable. Then another one is this is a dynamic variable. For example, the array. Array. So when we define the 100, we don't create 104 bytes of the data structure integer I. Okay? Instead, because if we have the 1,000, 10,000, the process size will be really big. It should be really big. Instead, it has only the location, reference of somewhere in your memory. They are free. This is called what? In C program language. Pointer. This is a pointer. So if you understand such a process data structure, you can a little bit easier to understand the pointer. But if you have the pointer, it will be complicated. Because to address that problem, we have object-oriented programming reference. So we can instantiate, create the object. It's the same thing. For the dynamically allocate the data. So if we create the object, then it will be stored somewhere in your memory, then return only address. So address will be stored. So using that address, we are able to. So that is the reason when you copy such a reference, then it will copy only the memory address, not this one. It's a shallow copy. If you want to really copy this one, it's a deep copy. You need to, each and everything should be copied. Okay? So this area is called heap. What is a heap? Data structure. Everything is a data structure. In your data structure class, you learn all of this. The heap is, for example, one of the heap area is 10, 5, 6, 2. It's a different types of tree. Binary tree is the left-hand side, the parent is bigger than left subtree, less than right subtree. But the heap is the parent is always bigger than this one. Okay? Which means it grows up like this. We can use such an idea. It's not actually exactly same the heap data structure, but the heap is growing this way. We can store something data, but it's dynamically allocate the data, like mostly the reference or the array or the such array data will be used here. It doesn't keep all the data structure inside the heap that has the reference address of the memory area. Yes.
So the heap stores the references to.
Yes.
Okay.
Yeah. To the memory space. That is the reason it's called the dynamically allocated data. It's not fixed. Like the primitive data type integer I is 10 will be created here. Okay. But the dynamic like the array will be. So we will have the location of the memory. So this is a heap area. Okay.
The pointer points to 400 bytes of memory space, right? Still, even
400 bytes.
for your example of I of 100.
So for example, I of the 100.
Yes.
So somewhere in your memory we need the 400. Yes.
Since we are
But it's
using
not the part of inside your process data structure because it will be. We don't. If we create the 400 byte the memory space here, we are not sure whether we are going to use all of them or not. Okay. So instead, it has a starting area over here. In case we use the 3940, so it will be increased here, but it will not affect our process, the structure. Okay. Another thing is, so sometimes definitely it's a temporary space, which means if the roof, the block is done, we don't need such a data. Okay. So from time to time, also, even though this is the variable defined here, but depending on the logic, some of the data we don't need more. Okay, but it's still here. Okay, the heap between the heap and the stack, we have the here. So to address that problem, from time to time, the garbage collector is the programming module. So of what? The compiler. So each program compiler has a garbage collector module that will check from time to time all memory address whether this data is really exist or available or verified. So if not, so there's the address, but in that address, no, there's no data, then we will free up the disk. To free up between the heap and stack, we will have another programming module that is the garbage collector. So who provide that? The compiler. What about Java? Java has the GC, the library, okay, the class, but it is not recommended to use explicitly run the GC, the garbage collector. But sometimes you need to do that. Like for example, if you are processing the video is a lot of array and the sequence of the images. Okay, it cannot be freed up quickly. So you need to firstly run the garbage collector to make enough free space. So this is called the heap and the stack area. So there are four generic section of the process: text, keep the programming code, and then including the static, the library, and the data is global variable. Then there are two parts, the heap and the stack. Stack is temporary, so it's the top two. That is the reason it's the top, the higher address to this one. And then the heap area is a dynamically allocated memory. It's a generic. Depending on the compiler, it might be the more details, but this is a generic, the data structure used in most of the processes. So more details. This is the example of so this is a lower address. This is an example of the C in the x86. Probably you use the x86 in your microprocessor class. I'm not sure nowadays which microprocessor is being used. Anyone who recently take the microprocessor class? So 286. Any undergraduate student? No.
I haven't taken it yet though.
So 8086 or the x86 are used a lot. It's the IBM, the 16-bit processor. So, but it's basically most of the IBM the family, the comparable processor use the similar or the variation of this one. Okay, so let's see for example when we compile the program. So it's a lower address and higher address. It's a process data structure. You can see there are four parts. One is the text, data, and the heap, and the stack, temporary, and the more details. So like the object file. When you compile the source code, it will create the number of object file. Then, what is the difference? The object file, then executable file. Can you run directly object file? No, object file is compile the module. Okay, then like the class file. To use the class file, you should have the driver main. Okay, main class. So main class is the only driver to execute the version. So similarly, we need to in the other program languages, we need to link several number of objects. Then the main will be here. The main will be the function like the main class in Java. So almost the same idea. So it will be they are linked together. At this time, if you have the static library, okay, static library like this one, this is a static library, will be included as a part of the program code. All together by combining, we can link them then to create the executable file that is a.out file, for example. You can rename it if you want. This is a executable file, so this is a text area to be copied. Okay, good. Then if you have any global variable, will be located in the lower address of the other process, the data structure. Okay, then there are two parts. For example, environment or the ARGV, ARGC is for the parameter, like the parameter value of the main. Okay, that is also most outside what? Temporary variable. Okay, once the main function is done, we don't need. Okay, that is the reason we keep even such ARGC and the ARGV and the step. So most inside. So which means when the main is completed, which means the end of your program, this will be freed up together. Then will be the temporary, the main, any variable for the main and the variable for the inside. The main probably called the function, okay, and any other the growth, the temporary variable used in the here. And also similarly, the heap. Inside the probably one of the popular system library, system code, as we discussed last time, system library is the only way to utilize the operating system provide a number of API, system library. So to use the hardware, that hardware, okay, so like the 200, 300, or the Windows 32, Windows API. So one of the most popular system library is MLO. So memory allocation. Using the why? Because the memory is the primary storage, primary area to communicate with the CPU. In other words, CPU would like to access any information or data from the memory, which means there might be a way to reserve the memory area. At that time, you can use the MLO. So MLO is then such a basic system library will be stored here. Then the heap growth means any dynamically allocated. In between, if there is any the shared library, that code this one will be located here and so on. So this is the one of the example of the processor structure. It's the x86, which means who defined this one? C compiler. That C compiler is developed based on the CPU processor x86. You cannot use that compiler for the another, like the processor, because that processor probably cannot understand this data structure. So you should have the different C compiler if you are using different. That is the reason. Okay, so then the overall, this is the generic, the process data structure. Okay. Any questions? It's fun to see the details of where can you find such a detailed data structure? How many bytes are allocated initially for this and this? You need to look up compiler. And compiler program inside it has all the details. For example, one of my project in my compiler class is to develop the compiler of the PCAT. I never heard until I took that course. PCAT is a very simple program language. PCAT, probably you can search. That is one of the most popular compiler, the program language for the educational purpose. It's a PCAT compiler. This is one of the very simple, but this I think the worthwhile if you want to study. The compiler is even though there are the C added, not C. I used the C when I took that course, but nowadays there is the Java. Java the library for all the compile the process. You can develop the compiler using the Java. So much simpler. So because when you are using the C, it is pointer level is sometimes the 16, 17, 18 depth. Because the compiler itself is like it's a recursive programming. The keep checking inside until you find if we have the if then else. So if next something the option and the inside check the recursively. If not, going back the back propagate and check again. So sometimes it will be the pointer will be the 16, 18 the depth. So you don't know where is the error. In case something the core is something the error in the memory. But the Java is much easier. So this is one of the educational purpose, the program language for the compiler. Then, if you want to see the details of the data structure of such a process, you can look up the documentation of each compiler. Then you will see the detail. Then it will be easier when you develop or when you have the problem on the not programming level, in the memory level. Something it return the memory address, then something else. If you understand the data structure of the process, it's much easier to understand the meaning of that. Okay, so this is the process. So let's see some other information using the slide. Okay. So we know what is the program and the process. Then this is the generic data structure, and depending on the compiler, it may be the varies. But this is a basic one. This is one of the examples. Oh, by the way, the process state. Then go back to mention. So before that, I do not explain how to create the process from here to here. When we double click or when we type a.out, I just say that we can create the process using this data structure. How? How? So if you are developing the operating system, one of the main job of the operating system is to able to create the process. How can you create the process?
The command for
Command the system library. So we need to use the system library. In other words, operating system should provide a function or API to create the process. So before we talk about the details of which library, which system library, so think about first, how can we create the process? We need what? Memory. So that is the most important part. We need the computing resources, specifically the memory space. So using the probe inside of that library or whatever, so it will use the malloc to allocate the memory address. It's a free space. So system library, operating system provide to the system library that is called the fork and exes. It's always two. So that makes us confused. But we will see why. Okay, before we talk about these details of the system library, as we discussed the last time, the first time when we start up the operating system, what happened? Which one will be? The kernel. Okay, kernel will be started. Then the operating system assign ID. So this process ID is the identifier. So they don't care. Operating system does not care name of process like the a.out or the msword.exe. No. Instead, it uses only the process ID. So kernel process is usually number one. Some of the operating system assign the 0. Okay? then the 0 create the 1. But at that time, it's not to protect the kernel process, it assigned the 0. Then this kernel process create the kernel thread. We will talk about what is the thread and the kernel thread later. But the first one will be act as the kernel process, first process. Then this is another the important characteristic of the operating system in terms of process. Always operating system create the new process from current process, which means there is so if one is a current process, then this one create another process. This is called the child. This is called parent. Then assign new process ID, that is 2. Then parent process ID is set as the 1. Okay, always parent and child relationship. And we can create another process. Then if the 3 is the current process, but it needs another process, then create this one. Okay, then at the time process ID is the 4 and parent process PPID is the 3 and so on. So then eventually this will be like the what? Tree structure. So operating system, current operating system, most of the operating system use such a process tree structure, parent to child. Then when you create a new process, always starting from the current process, create its child process. Okay, so this is the process tree and the process tree structure. Okay, then at that time, so for example, one would like to create the child process. At that time, we can use the system library, the inner row. The first one, the fork means first when we create a new process. Okay, I'm the one. I'd like to create a new process. At the time, copy. This is just clone. Just copy the me. So which means in terms of memory structure, so we will minimize. So this in the memory. This is OS. So this is A dot out here. So if you need to create a new process, okay, then we are going to use the fork. The fork means the meaning of the fork system library is exactly copy. This is a fork. Why? Process use memory. We need to first find the space in the memory. At that time, we can just copy of this one. Then, when you copy, it doesn't copy each and every detail. Okay? We need only the data structure. It's the allocation. Copy means the allocation. But this time, it's exactly the same thing, but except this area, this area, programming code. We don't have to. Later, this new process is the first during the fork is the same thing, clone. But eventually this will be another process like the swap. Their programming code different from the kernel. So we don't have to copy, instead this will be shared. Okay, actually not copy, this one is just a point, shared. In other words, it looks like this. We have the text and the data and other. After fork, it's like this one, shared text part. It's exactly same, okay? The programming code, because they are shared. So that if the fork is successful, during the fork, what happened? Actually, check the resource and assign the process ID. Once this one is okay, which means it's ready to be really new process. Really new process means this is identical. We need to replace. For example, this one is for example the PS. Here. So this is the bash shell terminal. So it's a shell programming, as we discussed last time. The shell program is the interface. So from the bash shell, I try to create a new process PS. I try to say PS is the Unix command or Linux command to show the list of process. Or LS. LS is a list of the file. Okay, you will learn in the next exercise lab, the basic Unix or Linux command. So when you type the PS, that means new process. The folder PS will be created. So first time EX the fork. Fork is the copy. A is exactly same. So this is a bash shell in this case, and this is a bash shell. So exactly same thing, but different location of the memory except the data, the text, programming code. So then if the fork is done, fork means just clone to find the resource, memory, especially memory resource. Also, the assign the new process ID 7, but they are the same. Then the after fork is done and the load the new exec means the load the new programming code to the text. Then this will be separated and PS will be loaded. Where's the PS? If this one is a popular application, it's /bin and PS, or sometimes USR and bin and PS, programming code. This will be loaded into the here, and it will be the new process as a child of this one. In this diagram, it will be this one will be PS and this, like this. This is how to create the process. Always two steps, fork and exec. So fork usually allocate the resource, hardware resource. It's a clone of the parent. Then if that is done, then we can load the new PS and the program code. So if you practice the exec, you need to specify where is the programming code. So that is beside somewhere in your hard disk drive. Okay, that will be loaded. Then this will be the parent and the child relationship is still there, but it's separate the process. Then this will be PS. There is one more. This is a PS. This is a bash shell. Wait. So why PS? This is child process. Why PS is running? What about this one, parent? When you were a kid, if you play outside, your parent will wait for you until you return. They are not doing anything. So during that time, the parent process, there are two options. Parent process can do other job continuously. However, if you take a look at the terminal or bash shell or something command line, while you are running the program, what happens? Just you cannot do any other thing, right? So if you tie there's the prompt and the PS is running 5 minutes, for example, can you do any other